high gas sensitivity, another satellite and sensor from another satellite. Thank you.
Okay, thank you, Mbak Sasvina.
I think the chair is loose. There's a problem with the chair. Hello,
Yeah,
Bu Rika? Still there? Okay, just a moment. Since Bu Rika maybe have a technical problem with the Zoom account, so maybe one question from me to Sasvina regarding to the unit more for meter cubic. So how can identify the concentration is high risk for the environment or our health, for example? Can you explain what's the unit that usually used in concentration of the CO2 or something?
Okay, thank you for the question, Ms. Agustan. I use the this is the classify high gas and lowest the concentration with the best of present up to today. This is a range, and this is the range is class. And this class calculate with person with the person with the person correlation. Yeah, from the person correlation, the range if range 0 until 0.01 is a very low, classified like that, and if hasil 0.05 is very high, like that.
Okay, thank you very much for your explanation, Bu Sasvina. Is there any question from the audience? Yeah, Karina, please.
Thank you for the opportunity. I want to ask to Miss Sasvina. So from your result in this slide, we know that each city's origins in West Java is we consider is as high with carbon monoxide concentration. What do you think the reason for to cause this result? Thank you.
Thank you for the question. I think because the carbon monoxide is a gas and gas is very very easy to spread with wind. I think the CO concentration in industry area carried by the wind to another area in West Java. That is and the value in another regency is high. I think that's a reason, and maybe another reason is any other factor such as gas from motorcycle that can influence the high gas concentration in its regency, but in this research is not exam this. Yeah, like this. Thank you.
Okay, thank you for the answer, Miss Asvina.
Can I ask something, Asvina?
Yes, sir.
Yes. it is great that you have been doing coming up with the distribution of carbon monoxide in the whole West Java area. Appreciate that. Now the question is the one that you put a red color, meaning that the content carbon monoxide content is high, right? So in this case, is it already achieving the a dangerous level for health? And if it is so, then what one should be doing concerning this? How to mitigate such kind of danger, if any? Yes, please.
Okay, from high or not, because the CO level, I think in ISPO is classified with high or not, with healthy or not healthy. But in this research is not find health or not healthy. But from this class is can show healthy or not healthy is high is not healthy. Yes. So to lose the CO, we can uh, uh, make a green area in industrial area in this zone, because in this zone is full of industry area. I think like that, and should use green area uh, to remove the concentration CO. I think like that.
Okay, thank you.
Okay, is there any question?
Hello?
No? Okay,
I
maybe
am
since
Badr bin Hisho. I have a question concerning the ground measurements. If do you take into account the ground measurements so to make any correlation between what is estimated and what is measured in situ? That's my question. And I would like to thank you so much for your work. Your presentation was clear.
For the ground correlation, right? This for the ground correlation. From the ground correlation, I use industrial CO emission from environmental agency in West Java. But this is the industrial correlation emission is just the industrial emission that just one years in West Java, and this is from many industry area. In Bekasi is egg industry area, Karawang egg industry area. Is I sum the industry, and I get a reference that get this value. But this is in different unit, industrial CO emission in microgram per meter cubic unit, and CO Sentinel 5 in mole per meter cubic. But in I use percent correlation to get the correlation. It's I read the many paper is it's okay if the unit is different. I think like that.
Clear, thank you.
okay, thank you very much, Mr. Bad Ben Mihicho. So since the time is already finished, so thank you very much for the Sasvina for your clear presentation. Thank you very much, and please give applause to Bu Sasvina by reaction.
Thank you so much.
Okay, thank you. So we move to the second presenter for this session. The title is Potential Leachate Contamination from an Abandoned Landfill Site in San Mateo, Rizal Province. Insight from Geological and Electrical Resistivity. Will be presented by Ariane Eno Oinin from Mapua University, Philippines. Is the author is here? Hello? Is the authors of the from Philippines is present in this room? Paper number 1570974869. So maybe we're still waiting about 2 minutes. Maybe committee can, is there any authors of the paper in the main room maybe? Is still not joined in the breakout room? Hello? Okay, so according to the committee that there is no participants or presenters from Philippines right now join in the conference. So maybe we move to the directly jump to the fourth presenter, determining the impact of a dam on the natural hydrosedimentary dynamics using remote sensing and GIS. This paper written by Badr Ben Hicho from Geophysics and Natural Hazards Laboratory, Geopark Research Center, Scientific Institute, Muhammad V University in Rabat, Morocco, Muhammad Daki from Gripom BirdLife Morocco, Nadia Muhammad, Geophysics and Natural Hazard Laboratory from Geopark, also from Morocco. So the authors is already in the room?
Yes.
Oh, okay. So please,
Yeah.
the time is yours to share your presentation
Okay.
this session.
Thank you
Please.
so much. Okay, I'll try to be fast since the time is not really will not be enough to present everything, but I will try to be quick. Thank you so much. Well, I hope you are seeing my screen.
Yes.
Are you able to see my screen?
Yes, we are able. Now presentation mode.
Okay.
Full screen.
Yeah. Is it all in free now?
Yes. Yes, yes. Very clear.
Okay. Awesome. 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 Hello, everyone. Welcome to this presentation titled Determining the Impact of a Dam on Natural Hydrosedimentary Dynamics Using Remote Sensing and GIS. We took as a pilot case of this approach the case of the Hassan Dakhil Dam in southeast Morocco. As you just said, Professor it was authored by me as the first author, Professor Mohammed Daki and Professor Nadia Mhamdi from the Scientific Institute of Rabat, University Mohammed V, Morocco. Well, this study delves into the critical interplay between dams and natural hydrosedimentary dynamics and it discuss the disturbance of the hydrosedimentary dynamics, the natural regime, the natural process of natural hydrosedimentary dynamics on the downstream, on the natural process of this sedimentation. As you know, the importance of mudflats in natural wetlands and their role in sediment accumulation cannot be overstated. However, our ecosystems face significant disruption due to human activities, and particularly the influence of dams on hydrosedimentary dynamics. And this study is aimed at assessing the impact of dams on ecosystems and downstream hydrology by modeling soil erosion and estimating the sediment rate that is blocked in a dam reservoir. Our methodology involves an integrated geomatics approach using the revised universal soil laws equation, Russell. We use also remote sensing for the data, for the satellite data, so to model it on a GIS as a software or a platform where we can calculate the factors of the Russell equation. Focused on a pilot case, as I said, which is the mentioned dam. Our aim is to quantify the hydrosedimentary dysfunctions caused by the reservoir and simulate sedimentation rates. Well, this slide highlights the geographic location and characteristics of the Hassan Dakhil Dam. We explore the catchment area and analyze elevation ranges and dissect rainfall patterns. Moreover, we meticulously explore the unique data associated with sedimentation within the dam's reservoir, offering a comprehensive overview. Our methodology involves estimating sediment inputs using Russell and Williams model, alongside remote sensing data, satellite data, GIS for the data modeling, and remote sensing like digital elevation model to calculate and to model for the modeling of the flow direction, for the water, the direction of water, the hydrology, for the modelization of slopes and their impact on the sedimentation process. We also we use various parameters for modeling erosion. We apply the Russell model to understand the factors affecting, such as rainfall erosivity, soil erodibility, slope length, land cover, and erosion control practices. The utilization of GIS, as I said, helps us map erosive factors, including the mentioned factors like land cover, soil erodibility, rainfall erosivity, and topographic factors. These maps in this slide, they visually represents each factor's influence on erosion. And we also showcase a map as a result of this modelization. We showcase a map illustrating the sensitivity of soils to water erosion within the catchment area, presenting statistics on erosion rates across different categories. like you see on the map. Our calculations estimate the sediment delivery ratio and net erosion at the dam. We validate our model by comparing estimated and measured net erosion values. We compare them to validate what is estimated. And since we use a lot of parameters to estimate it, we found that our validation results indicate a high similarity between estimations and measurements. And by the way, we're surprised about the results. They were very similar to what is measured on in situ. And we think that I think that we have do the same work in another place to see if it gives the same similarity, because it was very this what is simulated was very similar to what is measured, emphasizing, of course, the significance of our methodology. Accurate estimations hold implications for dams' operational efficiency and ecological balance, so that we maybe before building a dam, we can know at least its lifespan. We can estimate the sediments that can be blocked in this reservoir. If we don't maintain it, we can know its lifespan, and then we can maybe know a lot of informations that is related to the future dam before its construction. In conclusion, I can say that our methodology effectively evaluates soil erosion and sedimentation, offering valuable insights for assessing sedimentation rates and implementing tailored strategies. And this study contributes significantly to ecological preservation and sustainable management in dam catchment areas. I think that's the result of our method, our work, and I invite you to ask questions, engage discussions, and seek further elaboration on our studies, methodologies, findings, and application. Thank you so much for your attention.
Okay, thank you very much, Dr. Badr, from your kind presentation. So please give applause first to the presenters. So if there any question from the audience about this paper, about this research?
Yes, please. Can I ask
Yes,
something?
yes, please, Pak Arifin, please.
Thank you, sir. Thank you, Professor Badr, for a very interesting presentation. I just would like to know, in analyzing, or at least in modeling, which led to finally mapping of the erosion or sedimentation within the lakes or the dams. I just would like to know what is the most parameter or most dominant factors which influence the what you call it, the most dangerous level of erosion or sedimentation in this case. Have you already concluded to some analysis, firstly, and secondly, what to do if you be able to pinpoint certain parameters which are very dominant in influencing the level of sedimentations. Thank you.
Thank you so much. Well, it's a good question. What is the most dangerous or the most impacts among these factors? What is the most important for, that affects erosion? Well, if I think depending our work in this, it depends the area, the study area, and for us in the study area, we found that the land cover is the most important thing, and then the topography. So there are two similar factors that affects this erosion, and the third factor is the erosivity of raining. The type of this erosivity, it affects also the erosion phenomenon. But what is natural, for us, what is natural is not dangerous. The most dangerous thing is the modification, the impact of human activities on the natural process. We classify dangerous like the disturbance of this natural hydrosedimentary dynamics by the dam, because a lot of ecosystems in the downstream will be affected. A lot of species, aquatic species, will be affected by the dam if we do not manage this sedimentation as the natural process of its dynamic. So what is dangerous here is the mode of the management of dams, not the impacts of any factor on this, among this. Only if it is a human activity that is answered in the equation. If it is a human activity, like for example, cutting trees, for example, up the upper side of the watershed, it might be a dangerous activity which is related to the land cover. We will find bare areas more than the vegetation area, for example, and that will be a factor that is affected by a human activity, and it modifies the hydrosedimentary region. I think I answered to your question.
Thank you
Look,
very
Pak Arifin,
much.
is it clear?
Yeah, it's very clear. Thank you very much, Dr. Badr. Thank you.
Thank you so much.
Is there any question from audience? Please raise your hand or just open camera, open mic. For this is very interesting application of remote sensing and GIS for the soil erosion modeling application of the RUSLE. Any question? No? Oh yeah, Bu Reni, please.
Sorry. Thank you for your time, and it's really very good presentation. I just wondering about the impact for the rainfall. Is there any impact, extreme rainfall, for example, in this erosion and inside the model? Thank you.
Well, thank you so much, Professor Lorini. Yes, of course, there is a huge impact of rain and its type. The way it's raining impacts the erosion, of course. If it's like if it rains one time with a huge author of precipitation, it will impact, of course, the erosion, and it will drain, which will drain the sensible areas into the network of the into the network, of course, the hydrologic model. And for us, I think, as I said first, it depends the study area. If it is a study area that is arid, for example, or Saharan area, it will be other factors other than raining. Maybe it will be something else, like wind, for example. It will be a factor, a high factor, much higher than raining. And for our case study, we found that raining and the type of this of raining in this study area is the third factor in this among these 5 factors you see in front of you.
Okay, thank you very much.
You're welcome.
Okay, thank you very much for Dr. Badar for the sharing your experience in the soil sedimentation in the dam in the Morocco. So very interesting for us, yeah. So thank you very
Thank
much,
you.
and please give applause to Dr. Badar and his team for the authors for this paper. Thank you.
Thank you so much. I am a PhD student. I'm not a professor.
Oh, okay.
I hope I was clear, and I hope participating again in the rest of this presentation papers.
Okay. Success for your further study, yeah, and
Merci
get the
beaucoup.
Thank you.
PhD. Okay, then. Thank you. So maybe according to the committee, according to Dr. Iqbal, that should be the third presenter, Cristano Gulay from Philippines is already in the room.
Yes, yes, sir.
Okay, okay. So sorry for make this a kind of arrangement. Yeah. So the next chair also will be handled by Dr. Reni Sulistiawati. So Dr. Reni, please guide this the rest of the session, please.
Okay, thank you, Dr. Agustan. Due to some technical problem from Dr. Rika, so on behalf of the committee, I will continue this session. So the next presenter, the title of the presentation about performance enhancement of long short-term memory through unlearning relearning soil quality parameters data. So for Dr. Crisanto Gulay, you have 20 minutes, including for discussion. Time is yours.
Excuse me, am I the one who will present the video, or you are going to present it?
You can share your screens.
Actually, I'm having a technical problem in my internet connection, so I just use my phone to present or to join your conference. So I hope you can play my recorded video.
Oh, okay. So please wait a minute.
Thank you.
Dr. Iqbal, could you share the video?
Let me check first.
Is there a problem, Iqbal?
Yes, cannot show the video. I already download, but cannot show. Wait a month.
Okay.
Mulai yang ruangan download itu udah diupload sih tadi. Siapa tim yang di ruangan?
Sorry, we talking bahasa.
Okay,
Maksudnya
I
nggak
will
bisa dijalankan? Yes.
Okay, I will download my video in my mobile phone so that I can play the video for you guys. So I think it will take 3 minutes or more than. So I will just process it. So maybe some other presenter will present first.
Okay. Okay then. Just a minute. I will try also.
Parameters data. Good day, everyone. I am Crisanto Gulay with my co-author, Dr. Arnel C. Pajardo. Our title is Performance Enhancement of Long Short-Term Memory Through Unlearning and Relearning Soil Quality Parameters Data. Researchers nowadays use different historical patterns to predict future data. Most researchers use it in disasters like floods, earthquakes, and storms. Some use it for business like sales, stock exchange, and so on. Some use it for health like disease identification, body mass index monitoring. Some use it for agriculture like water quality analysis, soil property analysis, and generally, prediction algorithm is very useful in many terms or aspects. The focus of the researchers in this study is a prediction using sequential data. With this, long short-term memory is one of the most effective algorithms. Based on our observation and experience in using LSTM algorithm, LSTM use 4 gates which include forget, store, update, and output. One of its challenges is that it is not immune to challenges posed by irrelevant data which reduce prediction accuracy based on various studies. In this study, our focus is on the forget gate, which uses sigmoid whether the data should be forgotten or not. The problem in this gate is some noise or irregular or irrelevant data are still used by algorithm which makes LSTM reduce its prediction performance. Another thing is, what if the forgotten data becomes relevant in the future? The forget gate is in LSTM totally forget the data, and when time comes that it is relevant already, there is no function that can be used to do the task for the forgotten data. With this study proposed a function that can be a solution for the said problem. This uses Z-scores to determine irrelevant data and relevant data, and also to assign weights importance. Irrelevant data are data outside the range of Z-score, and relevant data are data inside the range of Z-score. Instead of totally forgetting irrelevant data, we just use another data table for irrelevant data. As the LSTM model trains on sequential data, it continuously updates its weights. Our modification allows for a periodic unlearning and relearning of the model. This process is triggered by the important weights assigned to data points. Data points with low important weights are unlearned to reduce their influence to the model, while high importance data points are enforced through additional training. This figure shows the process of experimentation by comparing traditional LSTM and the modified LSTM. Each algorithm was trained using the trained data, and the model was created based on the traditional LSTM and the modified LSTM. The two models were evaluated by their accuracy, test loss, root mean squared error, and mean absolute error. We conducted a series of experiments to evaluate the performance of our modified LSTM on various tasks and datasets. Our results show substantial improvements in prediction accuracy when compared to traditional LSTM model. In here, you can see the test loss result. Test loss, in simple terms, measures how well a machine learning model performs on new, unseen data by qualifying the difference between its prediction and the actual outcomes during testing and evaluation. For all parameters, NPK, pH, temperature, humidity, rainfall, and the modified LSTM consistently outperforms the traditional LSTM in terms of test loss. So for the root mean square, or RMSE, it is a way to measure average magnitude of errors between predicted and actual values in a set of data. In simple terms, it provides a single number that represents how well a predictive model is performing with lower RMSE values, indicating better accuracy. So as you can see, the modified LSTM outperforms the traditional LSTM RMSE in terms of RMSE. For the mean absolute error, so the mean absolute error calculates the average of the absolute values of the errors, providing straightforward way to assess how far off prediction are from actual values. A lower MAE indicates better accuracy in a predictive model. So as you can see, the modified LSTM also outperforms the traditional LSTM in terms of MAE. For the accuracy indicates how well the model is performing in terms of getting prediction right when dealing with sequential or time series data. So the higher accuracy values indicate better performance, while the lower values suggest that the model is making more errors in prediction. So as you can see, the LSTM produce better accuracy performance. So for the result in nitrogen dataset, so this shows the prediction process for nitrogen. So as you can see, the total number of data in traditional LSTM was 2,400, while the modified LSTM is 2,200. So the modified LSTM archived 200 irrelevant data. So maybe because of the device malfunction, or there is no relevance to the data sequence, or it is outside the Z-score. This is the data set for phosphorus. So this is the performance in terms of accuracy. And this is for the potassium. So for all parameters, the modified LSTM consistently outperforms the traditional LSTM in terms of accuracy. So the highest difference in performance is the dataset of K, which is the potassium. Datasets where our modified algorithm outperforms traditional one with 90.65% difference. So for the conclusion, our modification to the LSTM algorithm presents a promising approach to mitigate the challenges posed by irrelevant data. By introducing adaptive importance, weight, and mechanism for unlearning and relearning, our modified LSTM can dynamically adapt to the data distribution. This allows the model to focus on most relevant information while minimizing the impact of irrelevant data. So for all parameters, the modified LSTM consistently outperforms the traditional LSTM. Moreover, the difference or improvements vary for each parameter, with the largest improvement observed for K, which is the potassium levels. The flexibility and adaptability of our approach make it suitable for a wide range of applications where LSTM models are used. Additionally, this modification can be further fine-tuned and extended to another deep learning architectures beyond LSTM. So the modification of the LSTM algorithm proposed in this research paper offers solution to the challenge of irrelevant data in training datasets. So for the recommendation, by introducing adaptive importance weight and a dynamic learning and relearning mechanism, our approach significantly enhances prediction accuracy. Future work may involve refining and extending this modification as well as exploring its applicability in various real-world scenarios. Moreover, this modified LSTM approach is recommended for continuous sequential data that requires machine learning techniques that encounter too many irrelevant data. And that's all for my presentation. Thank you for listening.
Okay, thank you very much. First, please give applause to Mr. Krisanto Gulai. So now I'm open for the discussion or question from the audience. Is there any question?
Yes, please.
Oh, okay. Pak Arifin, please.
Yes, thank you, Ibu Moderator. Mr. Gulai, I just would like to know, since you are not showing the LSTM, modified LSTM, could you show some mathematical formula or diagram or something like that? What is the difference between the LSTM, the traditional one, versus the modified one? And secondly, I'm just wondering if we could be informed regarding what is the definitions of the irrelevant data in this case? How do you infer if the data is irrelevant or not? Something like that. Thank you very much.
Okay, thank you, Pak Arifin. Mr. Gulai, you can answer the question.
Thank you very much for that question. So first, for the first question about the difference between traditional and modified algorithm. In traditional, they use just a sigmoid function wherein it uses 1 and 0 in order to forget or input the data. So they use the traditional LSTM use sigmoid function. While in our modified function, we use z-score, which identify the average mean range for the set of data for the data set. And for the second question, which is regarding to the relevant, can you repeat the second question again?
Yeah, I'm just wondering if there is some kind of definitions in your algorithm to judge if the data is being irrelevant or otherwise it is relevant.
Okay, so the data becomes irrelevant when we use z-score. So if the data is outside the scope of z-score, functions in that is included in the modified algorithm, it is considered as irrelevant. But if the data is inside the scope of Z-score, so we consider that for as relevant. And if the data is outside the Z-score, which is irrelevant, we just put it into another archive or another data table. And the difference is the traditional LSTM totally forgets the data, the irrelevant data, while in our side or in our algorithm, we just archive irrelevant data. Maybe in the future, we can reuse that irrelevant data if that irrelevant data become relevant in the future.
Okay.
I hope I answer your questions.
Yes, very much. And thank you very much, Mr. Gulai.
Thank you.
Okay. Is there any other question from the audience? Maybe I have a small question for you. So related with the time resolution in this model, what is the time resolution you use?
Regarding to the time resolution or time consumption of training the model, it took 20 minutes, 20 to 25 minutes when using central processing unit. But when we tried to use GPU with the specs of GeForce RTX 3060, it only took 8 minutes to process the training model. So in times that in terms of computational requirements, it only triggers when relevant data become irrelevant and irrelevant data become relevant. So the additional process only triggers when that scenario become when that scenario go during that scenario.
Okay, thank you very much. So is there any question? There is still remaining maybe for one short question. Iqbal?
Yes. Thank you, Dr. Rani. So I would like to ask your data set about the nitrogen, phosphor, and what more? I forgot. The potassium. How do you obtain this data? Because you didn't have. Thank you.
Regarding to our data, we just use the data from the Kaggle.
From where? Excuse me.
from Kaggle website. So it is an online web-based data set.
Okay. Is there enough, Iqbal?
Yes, enough. Thank you.
Okay. So thank you very much. And once more, please give big applause to Mr. Krisanto Gulai. We will continue for the next presenter. Wait a minute. Okay, the next one, the title is Monitoring of Land Use Change Using Google Earth Engine for Agriculture, study case Indramayu Regency. Is there the authors of this paper in here already? Pak Wawan Hendriawan?
Yes.
Okay. Okay, Pak, so you have same with before 20 minutes, including for discussion, so you can start now.
Okay, I will prepare my presentation. Okay,
Okay.
can you see my presentation?
Yes. You can start.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you for the time. I will present my research about monitoring land use changes using Google Earth Engine for agriculture in Indramayu Regency. This research is collaboration with my colleagues in Indramayu, in Ibnu Khaldun Bogor, and Wilalodra University in Indramayu. This is our team. Myself, Pawan Hendriawan, and Mrs. Yuliana, Mr. Yugo Kumoro, Mr. Okta Pajar, Mr. Mujianto from BRIN, and Mrs. Gita Fitri Laksmi from Ibnu Khaldun University, Mrs. Tita Nistiani from Bapeda Indramayu, and last, Mr. Yudi Mahmud from Wilalodra University Indramayu. Our background research is in 2045, Indonesia has visioned Indonesia toward the world food storage. We can see in the chart that Indonesia is fourth largest rice production in the world, and in ASEAN, Indonesia is the most largest production in rice. This is the main capital to Indonesia toward the world food storage. And if we see in the country level, the province of East Java is the most largest production in rice. The next is Central Java, and the third is West Java. And if we see in district level, the Indramayu Regency is the first number of the rice production in Indonesia. So we think this is the position of the strategic position and good position for Indramayu to support the national fruit granary in Indonesia. And Indramayu Regency has area of 115 hectares of rice field, the largest in West Java, and part of them was declared a sustainable food agricultural land. We can set LP2B, covering an area of 86 hectares. And in the regional medium-term development plan, Indramayu has vision based on agriculture. But the question is the relevant in the future. And in Indramayu has a problem. There is a lack of spatial information about existing agricultural land in Indramayu. So because the data in the text and in the spatial is not well compared. And there is challenges in Indramayu for the agriculture food security. There is the issuance of Presidential Decree number 87 of 2021 concerning acceleration Rebana area development. This Rebana acceleration development is consists of Cirebon, Majalengka, Subang, Indramayu, and Sumedang. So this area development, of course, will affect the land use changes in Indramayu. So this is the challenges. And the other challenges is the climate change and environmental pollution. There are threats to rise agricultural production in Indramayu Regency. So there is a problem in the view of data. The first is there is the lack of spatial data, spatial data information on rice field for past, present, and future for prediction in other process and analysis. And how does climate or carrying capacity of land affect agriculture? And third is the agricultural-based development vision of Indramayu Regency still relevant in the future of an economic aspect? And last, how to maintain a sustainable food agricultural land in relation to development of Urbana. So I think we need to assess the problem in the view of data. The need is tool or dashboard for monitoring past, present, and future prediction spatial information data. So our objective in research is utilization of big spatial data time series satellite imagery to see the potential of Indramayu Regency as national food bank. Second, analysis of time series satellite imagery using machine learning to see past, current, and predict future for land cover of rice field. And the last is participatory mapping method for classifying paddy land cover in Indramayu Regency. This, our method in this research is we use the medium satellite imagery such as Sentinel-2, Landsat, and other medium satellite imagery, and we use two high satellite imagery such as Google, GeoEye, Worldview, and etc. And we create the normalize different vegetation index, normalize different water index, and bare soil index from Sentinel-2 and Landsat, and we use paddy production data and topographic data. And for classification, we use machine learning supervised classification. We create the data training and data testing by two methods. The first method is interpretation using visualization in OpenStreetMap, Google Earth, or high satellite imagery such as GeoEye, Worldview, etc. And in this data training and data testing collection, we propose the participatory mapping. This is participatory mapping can adjust the collection of data training and data testing. By the collection of data training and data testing, we create the dashboard to create data set and create the land use and land cover classification time series. And afterward, the data can see the potential and prospect for granary in Indramayu and Indonesia. And our result is participatory mapping framework. We create the framework, input the data to use in the Google Earth Engine. The input data use Android device using QPild Cloud. We can input the data and capture data about the location, about the coordinate, and capture the condition, photo, video, and send by internet to the QuantumGIS and database, and validate in QuantumGIS and analyze it, and we can use in Google Earth Engine to classify the land use and cover, and we can also visualize in WebGIS. We visualize the WebGIS in uploaded in Amazon Web Services. And the next result is the dashboard. Dashboard in Google Earth Engine. The dashboard is application for creating the dataset. So this dashboard, we can create the dataset from the 2019 to until now. So this dataset is consists of Sentinel, the 13 band, and edited by NDVI, NWI, and BSI. This dataset can visualize, or we can see the band with natural color view, NDVI view, BSI view, and normalized different water index. And after we collect the dataset, we can classify using the classification, supervised classification. The first we create training and testing data. This data training and data testing is best visualized and interpretation in Google Earth Engine with the data in the dataset that's here. And we create the dashboard for classification using Google Earth Engine. we use pixel-based random forest algorithm, we can automatically create classification for land use and cover classification. We have 5 class: water, settlement, paddy field, barland, and sherm. In this data, we can see the Indramayu is dominant by paddy field, and overall accuracy for this classification is about 74%. And we create the classification using GAA, using pixel-based and object-based, but we use in sub-district level because if we try in the area of Indramayu, that is an error because the volume of data. We can see the overall accuracy in the sub-district pixel-based is more higher or better than object-based classification in some area, in same area. And in the dashboard, we create time lapse so we can see the different or changes land use and land cover. We can compare with the data land cover in Indramayu in spatial planning data, and in dashboard we can compare with the rainfall data using chip and other data. And the conclusion of our research, this is the preliminary research. We in this time we create the dashboard, and the dashboard of Google Engine was successfully produced by generating time series dataset, integrating and classifying image data using GAA, monitoring land use, land cover changes effectively to support and contributing to inform agricultural development decision for enhanced food security. And by our using the machine learning method, the random forest pixel-based land use land cover classification is better used in middle sector imagery than object-based classification. Thank you. That's all of my presentation. Thank you very much.
Okay, thank you very much. Please give applause to Pawawan for his presentation. It's very interesting. And it has even still preliminary, but it has many results. So from the audience, is there any question, comment? We still have about 7 minutes. You can raise your hand or open the mic. Is there any question? If not, I would like to ask a small question. So in your presentation, you mentioned about it can be used for analyzing the past, current, and future. But in the presentation, sorry if I'm a little bit missed, but I couldn't see the future. Could you explain a little bit more for the future condition or prediction or projection?
Okay, thank you for the nice question. In this research in this year, we focus in the creating the dashboard. So by the dashboard is create the data set, Sentinel, Landsat on other data, and we create the dashboard for classification. In the classification, we until now we just create classification for the time past and present. But for the future, we not yet, until now, we not yet the analysis. In the next year, we can continue our research, and we use more algorithm, and we can predict the future prediction for land use and land cover, and we have to classify the drought index, the drought index for Indramayu.
Okay, thank you. Would be very interesting. So hopefully we can see the result for future, including the drought index for the next AGERS. Next year AGERS.
Yes, because the one El Nino, this time El Nino, we have to see the drought index in Indramayu can affect the agricultural.
Okay, thank you very much for your answer. So is there any question from others audience in this room? Yeah. Hello, is there anyone open the mic? Okay, if not, maybe we can give big applause again to Mr. Wawan and his team, and hopefully it can continue for the next step for his study.
Thank you very much for the time. Assalamualaikum warahmatullahi wabarakatuh. See you in the next year.
Yeah, see you. Thank you. Waalaikumsalam warahmatullahi wabarakatuh. Okay, so we will come back for the second presenter. Wait a minute. So potentially said contamination from an abandoned landfill site in San Mateo, Rizal Province, insight from geological and electrical resistivity. Is there the authors in this room? I will calling 3 times before we conclude. Mr. Aryan Enoni Jeso, Alfrelinda Lee Grace, or Carlo L. Queanu. Sorry if I wrong to mention. Is there any authors or co-authors? No? No one? Okay, while waiting the last calling, so please fill the attendance for this room and this session. And I would like to remind all of you, there is still next session will be start at 3 p.m. Jakarta time or Surabaya time, and then tomorrow, after all the presentation, we will have the best presenter, both for student and general presenter. So please join again for the session. So the last one, is there any authors? Arion Enoni, Alfrelinda Lee Grace, and or Carlo L. Quano? No? Okay. So before I end this session, could you please open your camera so we can take a good group photo for this session? And thank you very much for all of your participation and for all the presenter and also the discussion. Okay. 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 I will count for 3 for the photo. I will wait a little bit. Okay, so I will take a photo. Smile. 1, 2, 3, smile. Okay, once more. 1, 2, 3, smile. Okay. Okay, thank you very much all.
Thank you.
Thank you very much.
So
Thank
we
you.
will meet again in the next session. Maybe it will start about 3 p.m. and don't forget to join tomorrow also for the best presenter. Thank you and see you next time.
So we have a break about 15 minutes, yeah, Bu Reni, and then back to the main room, and then we can select again for the next session. So the next session is GIS and city development and also low altitude and close range remote sensing. So please feel free to join which session that do you like. Okay, see you in the next parallel session.